Let's do the layout of a NOR gate. We know the standard schematic for the NOR gate is two PMOSes and two NMOSes. This is ground, this is VDD. So we have and labeling the gates. This is the output terminal out. This is input 1A. This is B. Here also it is A and B. But we know in the layout the MOSFET will look like this. So this is the source, gate, drain. That means it is easy for us if we draw in this way. If we draw in vertical, things will look like this. But if we draw in horizontal, source, gate, drain, then it is easy for us to understand the layout. So I am redrawing the same schematic in a horizontal way. So we have two PMOSes. I am drawing the two PMOSes. We have two NMOSes also. I drew two NMOS also. This is PMOS. And this is the ground terminal. And we have VDD also. Now, suppose this is the terminal A. So this is this MOSFET. This MOSFET is this MOSFET. So drain of this MOSFET is connected to VDD. So I am making that connection over here. Drain of that MOSFET is connected to VDD. And the source is connected to the drain of MOSFET B. This is MOSFET B. So source of that is connected to MOSFET drain of MOSFET B. And the source of MOSFET B is the output terminal. It is connected to the drain of two NMOSes. So before drawing the connection, we know the inputs are same. That means the gate of the A terminals here we can connect together. Sorry, this is not needed. It's a single line. So input is common to A is common to this NMOS and PMOS. This B also common to NMOS and PMOS. So the source of this NMOS is connected to ground. So I am marking that. And the source of B is also connected to ground. I am also marking that. And their drains are connected together. And that common point is connected to the output. So that is the output. So this we can write as the output. So this is the terminal A. This is terminal B. And that is the output. So now it is easy for us to draw the layout from this schematic. This is not the layout. This is also the schematic. But we just draw in horizontal fashion, so that the layout is easy for us. Let us draw the layout. We have supplied net over here. It is the VDD supply net. And we have the ground net over here. So this is metal one. This red one is red or pink color is metal one. And we have 4 MOSFET. We have 2 PMOSes and 2 NMOSes. So I am drawing is very quickly. Now I am drawing the gate with polysilicon. So this is how we look like if we just put 4 MOSFET here. These two are PMOSs and these two are the NMOSs. So now we have all these 4 PMOS and we have this connection. We just need to connect them together. So first of all I am starting with the gate. So we know the gate of this PMOS is connected to the gate of this NMOS. So we can connect them together. This is the connection A. This is the one of the input A. And similarly we can connect the B also. This is B. Now these two connections are over. Now the source of this MOSFET is connected to ground, so we have to make that connection. That connection is made with metal one. Blue one was poly, so we are making this with metal one. So that is connected to ground. Similarly, this also connected to ground. So I am making that connection also. It will be more clear if you are confused now. It will be more clear when we do the layout in Cadence. Now this connection I have to make. That means the drain of this MOSFET to drain of this MOSFET. That is this connection. Okay. Now this will be the output terminal. So we will connect it later. Now let us go to the PMOS. And in the PMOS we already connected the gates. Now the drain of this PMOS is connected to the VDD. So I am making that connection. So drain of this connected to VDD. And the drain of this is connected. This MOSFET is connected to the output. So we already have this output over here. We can pass this through polysilicon. This metal one and poly is overlapping is not a problem. So this is our output terminal. This is having metal one. This is poly. And what the connection remaining is this source and this drain of these two MOSFETs. So we have one MOSFET over here, one PMOS over here, another PMOS here. These are the two NMOSs. So this is pretty easy for us to do the layout. There are some other methods to make the layout, taking minimal area. We will check that also when we do this layout in Cadence. Let's go to the Cadence and do the layout.
Let's create the schematic of the NOR gate. Then we will do the layout of that. New cell view. First we will make the schematic. Okay. Add instance by pressing I. We need 2 NMOSs. We need 2 PMOSs also. The PMOS width is, we are taking double that of NMOS, so instead of 240 we are using 480. Hide. Escape. Press F to fit to screen. Now before wiring we need ground and VDD. Ground and VDD we are using pins, input output type pins. VDD, ground, hide. Press F. Now we can wire them, and wire by pressing W. The board bulk is connected to supply. This is the output terminal. Bulk of the NMOS is connected to ground. Add input pins. Here also we are labeling A and B are the input pins. So it is A and B, and label A and B for the NMOS gates, and then output pin, capital out, hide, save. Now let's create the symbol for this schematic. Create cell view, from cell view. Okay, okay, press F, delete those things, we don't need them. Name you can put as symbol NOR. Okay, now create shape, arc, this is my symbol. This is not so beautiful, but it's somewhat okay. If you have time, you can make it more beautiful. Press F. Okay, I'm stopping here the symbol. If you have time, you can draw a neat symbol. Save. Okay, let's go to layout, launch, layout Excel. Okay, this is the line selection window. The layer selection window. Here also I am taking the cell height as 8 micro, so press K to start the ruler. Press F. Now add NMOS and PMOS. So first of all we add NMOSes. So this is one NMOS, and here is another NMOS. Now we have to add PMOSes. Shift P. Size is 480 by 180. That is exactly what we want. Now let's draw the supply rails with metal one. So we already selected metal one. This for VD. Let's copy that same for ground also. Can move this NMOS little bit higher. Okay, so first of all I am as usual I am making the gate connections. This gate of this PMOS is connected to gate of this NMOS, gate of this PMOS is connected to gate of this NMOS, and in the digital circuit we can make the connection with polysilicon. So in the layer selection window I am selecting poly. This is the polysilicon. Press R to make a rectangle. Press F. We have to move this. They are exactly matching. Similarly, we can draw one polysilicon line here also, or we can copy this polysilicon. Press F. Now you can move this. Let's check for any DRC issue. Assure or on DRC. Okay. Okay. Yes. We have minimum n plus implant issue where it is. Okay, Here we have design issue. Okay, we cannot make it like this, so we have to pull apart. Press F. The poly we have to draw. Press R. Press F. Now we have to add the substrate contact. We have to add N-well contact and P substrate contact. So go to create via metal to N1. So we can add more in row, but I'm using only 4. 4 is fine. So as we explained in the case of NAND gate, all things is applicable to here also. So I want a single N-well, so this should be connected. I cannot put it apart, and using N-well is connected to supply node. Now it is connected to VDD. For the NMOS, we need P substrate connection. Create via. So this P diffusion to M1. It's also 4 is fine. Escape. Press F and check for DRC. Okay. This DRC error is known to us. This is because the metal one in the source and drain are not connected to anywhere, so they are with minimum length, minimum area. That is the error showing. So now the basic connections are over. Now we have to connect the other things according to the schematic. We have easy things first. We have two NMOS sources are connected to ground, so we can make that connections in the schematic. So I am considering this as one source and this as the other source, so let's connect them to ground. Oops, we are using polysilicon. So in the layer selection window we have to select metal one, ME1. It's fine. Press R. Okay, scroll down. Press F. Similarly, we have to connect this also to ground. Press F. Now in the NMOS, the connection what is remaining is their drains are connected together and it is going to the PMOS. So we have to connect these drains together. Press R. Start the rectangle over here and again zoom. So they are connected. Now we go to the PMOS connection. So in the PMOS, one is connected to VDD and the drain is connected to the source of next one. So let's do that. I'm considering this as connected to supply. Press F, and the drain is connected to source. Press F. Now the output terminal is remaining, so we take the connection from here. So this is the output terminal from the NMOS. So we just draw a rectangle again. Oops. Now let's check for DRC. Ashura run DRC. Okay, okay, okay. So there are no DRC error. Now we have to make a via from polysilicon to metal one. So let's do that. Create via metal one to poly, hide, press F, make a small metal. We are just extending the metal one. Here also to remove the DRC error, otherwise it will show that the metal area of this is less than the minimum. Escape, press R. Press F again run the DRC. Okay, okay. So no DRC error. Let's label them and go for LVS. So we have A also. Okay, so this is VDD, this is ground, this is terminal A, this is terminal B, and this is output. So let's do the LVS. Okay, so a layout and schematic match. There are 0 mismatches over here. So the LVS debug window, it is showing schematic and layout match. Now as we did in the case of NAND gate, we can make this design more compact by merging these two MOSFETs. So let's do that. I'm just moving them apart and delete others. Let's delete these connections. Oops. So what we have to do, we have to merge these two MOSFETs exactly as F. Similarly, we can do that for NMOS also. Let's delete this. Press F. We don't need this much long supply rail now. Oops. Press F and draw a supply rail. This for VDD. I'm copying the same for ground also. We don't need this much big supply rail now. Press F. Let's go back to schematic and see we have the two connections to the ground. So let's do that. Let's do the second connection. Press R, press R, scroll down, fit, and this is a common node from the NMOS. This is the output terminal. Now we have to connect these gates together. Before that, let's do DRC and see any unexpected error happen. Okay. Yes. Minimum poly, minimum metal area. These two errors are known to us, so nothing to worry about that. So let's connect these two gates together. Press R. Oops, this is metal one. We have to select poly. So use PO1 for poly. Press R. Press F. Now as we did for NAND gate, there is no metal connection where the drain and source of the PMOS is connected. There is no other connection. So what we can do is we can flatten this cell and we can remove the connection in the middle. So I'm doing that. I'm selecting the two PMOSes, go to edit, hierarchy, flatten P cells. Okay, now I am removing the contact. There will be two contact and two metal, so I removed all these. Now we can instead of routing outside, we can route this here inside also. Oops, I have to select metal one. Press R. So there is no connection, so it is just a metal routing. So we can route. Plus R, F. Can make the routing like this also. Oops, I pressed F1. Okay. Now just put this. Press F. Press F. Now let's do the labeling of the remaining. We have what is remaining is VDD here, ground over here, and out is in the middle, so we can just label it over there. So we can save the area, so there is nothing coming outside. So let's go for the DRC, run DRC. Okay, is there anything missing? So what is the error? Field poly spacing. Let's check where it is. Oops, same error again. It is not well connected. Okay, do the DRC again. Yes. Now the minimum poly width. Where is the issue? Yeah, here small alignment issue we have. So delete SR. So DRC K. So no DRC error. Now let's check for LVS. So there are no mismatches, there are zero mismatches. That means we are clear in LVS also. The LVS debugging window says layout and schematic match. So I'm stopping here. I'm not doing the extraction. I just wanted to show how the layout of NOR gate is done and how the cell is flattened, how we can remove the metal and contact in between these, and this was the purpose of this tutorial. And thank you for watching. Bye.